Alright, so I'm doing the last problem on the first page. This problem is from period 3, but it applies to the other classes as well. So Sean launches a javelin with an initial speed of 21.8 meters per second at an angle of 35 degrees above the horizon. So we can draw a graphic, 35 degrees and 21.8 meters per second. So we're to determine the time of flight of the projectile, so we need to know t total. We also need to determine the peak height of the projectile, so we need to find y. So in order to find y, we need t up as well. This means that all we really need to find, since these are both things we can find using vertical information, we can just find v initial in the y direction, or in the vertical direction. So to do that, v initial in the y direction is equal to the initial velocity times the sine of theta, which is 35 degrees. So this is in meters per second. And we do that on our calculator. You get 12.5039. I'm going to keep all of these numbers just to be safe. If it was a final answer, I'd just be looking at that second decimal place. All right, now we also know some other information. We know that at the peak, our velocity in the y direction is equal to 0. This is because we start out with an initial y velocity of 12.5 meters per second. As we increase, we know that there is an acceleration in the downwards direction. When we hit this peak point, so this whole time it's traveling here, our velocity is changing, becoming smaller, till we hit this peak point where it becomes 0. After the peak point, it starts to increase in the downwards direction. We can also assume that this point and this point are at the same height, so which means if it's going to travel this far upward and then travel the exact same distance downward, our VF in the y direction should be the same as our V initial, but negative. So we have two options. We can solve for t up or t total. Since I'm required to find y, I'm going to solve for t up. Then I can just multiply it by 2 to get t total. So I can use the equation VF equals VI plus AT. I know my V final at this point is 0 meters per second. I also know my initial V in the y direction was 12.5. In my calculator, I'm going to use this big long number. Plus my acceleration of gravity, negative 9.8 meters per second squared, times time, which is what I'm solving for. So you subtract 12.5 from each side. So we end up with negative 12.5 meters per second equals negative 9.8 meters per second squared. T, divide by that negative 9.8. And we get T equals, so we got 50396 divided by negative 9.8. Oops, I forgot to put the negative. So our T total is 1.28 seconds if I round. If I multiply that number by 2, I can get my T total. T total is going to equal 2.55 seconds. So my answer here, determine the time of flight, 2.55 seconds. Now I need to determine the peak height of the projectile. So to determine the peak height of the projectile, I'm going to use the equation y, so the displacement in the y direction equals v initial y times t. This t needs to be t up. If I use t total, it should be 0 as the answer, plus 1/2 g, negative 9.8, t squared. So y equals 12.5 times 1.28 plus 1/2 negative 9.8 times 1.28 seconds squared. So I've got to plug that all into my calculator using some parentheses. 12.50396, that's my long number, times my t up, 1.28, plus 1/2 of my acceleration, negative 9.8, times 1.28 seconds squared. We're going to hit enter, and we get a y value of 7.98 meters.